Welcome back to Pop Goes the Stack, your front row seat to emerging tech, digital duct tape, and the slow unraveling of sanity in production. I'm Lori MacVittie. Brace yourself, because today we're going to talk about the most expensive lie in modern infrastructure. Logging is free. To do that, we're going to explore OpenAI's discovery that logging isn't free in a little bit of depth with our co-host, Joe Moses. Joel.
Good to see you, Lori.
And our observability expert, Chris Hain. Chris, welcome back.
Hey guys, thanks for having me. Good to be here.
No pressure. No pressure.
No, yeah.
All right. So what spurred this discussion was OpenAI reclaimed 30,000, let me repeat that, 30,000 CPU cores simply by tweaking Fluent Bit, right? Some logging. Now, they didn't rewrite the models. They didn't buy more GPUs. They fixed telemetry overhead. Because it turns out that your observability pipeline can be one of your biggest workloads, especially once AI shows up and starts generating logs like it's trying to win some kind of contest. So let's dive in and talk about what happened, right? So a little bit of the details and what this really means for regular enterprises that don't have 30,000 cores to begin with, but who want to make sure that they are optimizing every resource that they have. So Joel, you want to dive in a little bit?
Well, I mean, Chris, of course, is an expert in observability, so I'm going to defer to him to kind of explain exactly why Fluent Bit was so absolutely CPU hungry in this particular case. But this represents something that, the assumption is, and has always been, that observability or monitoring or logging is basically free. And it is free, but it's free in the same sense that air conditioning in the summer in Texas is free. It's absolutely free because you don't think about what it actually costs because you need it, and so that's one of the reasons this wasn't noticed. But Chris, why don't you tell us what was Fluent Bit doing that was so busy?
Well, so first I'll just say, if you really think logging is free, you've probably never paid a Splunk bill at a medium to large size organization. So
Good point.
Datadog?
Anyway,
Maybe Datadog bill?
So basically, Fluent Bit is running as a DaemonSet on all of their nodes, which means all of the nodes are running Fluent Bit, basically watching these logging files, reading the data that's coming off of them, and sending it off to some probably centralized logging place somewhere. I think they mentioned ClickHouse. Mm-hmm. So Fluent Bit is basically everywhere, and it's doing work on every single node in their network, in their all of their clusters. And one of the things that it's doing is watching for updates to these files. And actually, you brought up a very good point that I hadn't thought of, hadn't dug into it as deeply as it at that level of thinking. But basically, it was doing a bunch of overhead work that was not providing the amount of value that they felt was,
right.
good enough for the amount of CPU overhead that it was adding. So when you added up this extra work that was being done and multiplied that by the number of nodes in their system, it wound up that it's eating, I didn't do the math. It's like $1 million a month worth of.
That's a lot.
Something.
It was a lot.
Yeah.
It was a lot.
So effectively what Fluent Bit was doing is it wants to see whether a file has changed. It's a pretty simple operation. If you're going to watch for log file additions and you want to see if additional lines have come in, to get an update from the system that the system has new data attached to a file, or a file's been deleted, or a file's been moved, etc. And the facility to do that under Linux is something called Inotify. It's one of them. It's not the only one, but it's one of them. Inotify, though, on 64-bit systems, every single time you use it, it allocates a buffer space of about 1 kilobyte of memory. And if you call Inotify repeatedly on a large number of files, it allocates that memory and it deallocates that memory in rapid succession. And so what they were actually dealing with is the fact that they were allocating a whole lot of memory a whole lot of times through this Inotify interface. And so the fix was to simply turn that off and go back to something that's fairly simple. They just periodically scan the system to see what changed. And that solved the issue. The funny thing to me about that is turning off a feature like that turns off some functionality that gives you notifications faster, but it also didn't understand why necessarily. Just turning off the feature does not help you understand why the problem was actually occurring, and that's memory back pressure. And so what that shows me is that the solution to this problem was not fixing Fluent Bit. The solution to this problem probably was optimize your host system well. They were hitting limits and adjusting the limits or managing the limits, which is SRE work. That probably would have solved the problem too. It's interesting. If the simple fix is to turn off a feature, the real bug in the system is probably hubris.
Definitely. Yeah. One of the things I liked about the story before I thought about it at that level of depth was just the fact that, problems like this exist everywhere, especially in, large scale systems. You can pretty much just throw a dart at your architecture diagram, go dive into it. And like he was kind of mentioning in the article, is like really try to understand what's going on at a deep level, and just throw all your assumptions about, where things are, costly or where resources are being burned, throw all those away, start from scratch, and just really deeply understand it. And you're probably going to find something that you can, spend a little bit of time to optimize. Probably not 30,000 cores worth of optimization in most cases, but
No.
Still meaningful amounts.
Now, the article did point out something that I think is a good thing, and they found this problem simply by running system profiling, meaning they were measuring how many system calls were taking place and what types of system calls in particular that Fluent Bit was calling. And they came across one particular call. It's fstat at 64, which is a fairly expensive call that Inotify makes. And when they finally figured out exactly what function was doing that inside of Fluent Bit, they noticed that you could adjust that by simply flipping the feature off. I think you can learn two things for that. Number one is you should know how to run a system profiler. Number two is you should know how to figure out within an application that you're running where bottlenecks are. And this is a system bottleneck that occurred inside of Fluent Bit. So kudos to the team that found it. Now, as for the solution to turn off the feature, okay, you can do that. There's probably other solutions that rely on system tuning that they could have taken advantage of. But it is an interesting find. And it brings up a really important distinction, which is that, observability, again, is not free. It's not free in terms of storage, and it's not free in terms of CPU. And there's probably better ways we should be observing systems, aren't there?
Yeah,
Absolutely.
well, it also says that, 30,000 cores. So if you're reclaiming 30,000 cores, that assumes that 30,000 cores were working on observability, which, 10 years ago, we would have never believed you would need that much, right? Observability was, well, just write a log a little bit, write a little bit of information. But AI multiplies the type of information that you need, and then also the different places it needs to go. If it's collecting real-time stats about how the system is performing, what it's doing, how many resources it's using, that might go to one system because it's more real-time, almost AI ops like. And if you've got things like, I don't know, audit logs and, keeping track of what's coming in and out, that's a different system. So you've got multiple pieces of observability data that are absolutely important today. You can't skip it either.
Yeah. And the other thing is the amount of information. Chris, help us out here. Like, profile for us a particular system that is running an AI workload, and how many microservices is that, and how many log files, how many counter tables? What are we talking about? How much stuff is actually relative to 5 years ago? How much stuff are we monitoring?
My lord,
Well, you just think about it like your access log at the front end, the thing that receives that request.
Right.
Maybe 25, 10 years ago, that was the thing you logged. Today, you've got microservices behind it. So at least a span for every one of those. Hopefully, they're all generating their own logs about what they're doing at the point in time. Like the overhead of logging and tracing and modern observability practices can way outstrip that, original just one bit of processing you were doing on that one request. So it's not uncommon for the observability stack in an organization to be the predominant thing that you're spending money to run.
Wow,
Right?
that's wild. So you know, it's
Crazy.
good. I've heard it said that you can't optimize what you don't measure, and so I think that by default lets someone think that you should just collect everything and
Sure.
then store everything, and then you can optimize later on if you happen to need it.
Yeah.
But this is what happens when you measure everything, right? So what should someone do to prevent that from occurring?
Yeah, well, I mean, one of the other things about like legacy logging versus kind of more modern LLM things is like originally logging was a thing that some like guy wrote and said, hey, I'm going to leave you this little cookie in case this event ever occurs. But now it's like this arbitrarily large block of data that an LLM has generated that you might need to go back and parse out for, performance or for training your models as you go forward. So the volume of things is like no longer bounded by the number of requests that are coming in. It's like, what did the models decide to do with that request, and how much text did they decide to spit out? So that's another huge shift. But yeah, the other thing that's kind of happening is like the metadata that is associated with any particular log is becoming increasingly important. It's no longer enough just to say, oh yeah, it came off this pod on this node, and here's the message and whatever other attributes might have attached to it. Now you also need to know all this additional context, what model was being generated, what tool was being called, or some of these other things that just weren't originally there. So like the idea of having more structure attached to the log as additional info versus just having the log line be the thing that gets you all the information you need is a thing that's kind of evolving a lot as well.
It's
So,
tracing on steroids. Like,
Yeah.
I mean, that's crazy. Like, who
Yeah.
did what, right? It's the 5 W's plus.
Yeah. Who
You
did
have
what
to
and
know.
what was going on while they were doing it, and like
Yeah.
everything that
And
you
why
need to
did
know.
they do it?
Yeah.
Yeah.
Now we need to know why.
So-
My model, why did you do that?
Yeah.
So if you're doing a high degree of monitoring local to the same host where this is being generated, obviously you're going to get into situations like this, which are contention, where observability is contending with the active workload.
Yeah.
What sorts of things might we be able to do to reduce or how about eliminate contention? Can we observe elsewhere?
Potentially. I mean, so typically sampling is the thing that is done very heavily, right? Like I can't afford to take everything out of here, so I will take the ones that hopefully I have some degree of insight that they are important, right? If I'm doing a thing called tail sampling, where I can say, hey, this took too long, I'm gonna ship that up to the back end to figure out maybe why. But generally speaking, yeah, I think there's a lot more effort happening to kind of shift that observability work to other places than it's traditionally been. So you'll see a lot of eBPF based profilers, as well as just like auto instrumentation elements showing up in agents these days. So it doesn't help the too much data problem, right? Because now you don't even have to wait for the software engineer to go instrument his app. It's just done for you automatically. So now you've got more data than even the
Yeah, you have to pay attention to how it's doing it. I mean, you mentioned
Yeah.
sampling, and then I think to the different kinds of telemetry that we're collecting. And I go to, of course, I like the ops side. So I'm thinking about performance stats, what's going on, lots of numbers, lots of things that don't necessarily have a lot of change, one hopes, right? And, you've talked about this, right? Using sampling basically what's time series data in order to make sure that you get the important changes. Like, hey, something changed, you notice it right away, because you're not sending everything and having to comb through it. But it's also faster. It reduces how much bandwidth, CPU, I mean, everything that you need.
Yep.
By only taking what you need. So that's one place you can immediately look at to optimize, right? A high-speed telemetry plane for things like number-based metrics.
Sure. Yeah.
So-
I mean,
Sure, that's it. All right. Yeah, there we go, guys.
Absolutely.
That's the
You
whole
got it.
thing.
problem solved.
We got it. We're
So
done. Thanks.
what things are occurring in modern observability systems to kind of help this along? Like the ability to do, say tunable collection?
Sure.
is one.
Yeah.
So like on-demand collection of something. I don't need it right now, but I need to prepare for the time when I do need it. What's
Or
going on
like a
out there?
local collection, but that you can then drain a certain amount of history when you find there's a problem. So it's, instead of always on, it's like locally buffering
Hmm.
a bunch of data that maybe you wouldn't otherwise pay to store and forward. But when you need it, you can click the button and away it goes. Some of those concepts are very interesting, and they could even extend down to like the user device, right? So if I've got an app running on a phone, I can use a little bit of a ring buffer there to hold the interesting stuff, and then when things are really breaking and it's their client specifically, I can now start getting it instead of having to take all of the data from all of the clients all of the times. So that kind of stuff is super interesting, I think. But yeah, it's a never-ending battle between balancing what you need to solve a problem or to identify a problem and what you want to actually pay to have available to you.
Right.
Well, let's be fair. That came about because in the beginning, in the olden times, we didn't have when the deep
Yeah.
magic was born, we
When
didn't
dragons roamed the land.
Too much data was not the problem.
Yes.
No, right. It was almost a dearth of data, and
Yeah,
right,
exactly.
you couldn't solve the problem because you didn't have enough information. So we kept
Yeah.
adding information, and now we've almost got to the point where we have too much information. Now we can't
Yeah.
find what we need in that.
Yeah.
So
So many security events and things that occur, like the data that you needed to detect it was there. It's just it wasn't being looked at or whatever. So yeah, this is a problem that is new, is different than the problems we had 10 years ago, but it's still a problem.
Yeah, nothing says modern distributed system quite like spending more compute on observing reality than creating it.
Yep.
I mean, that's amazing, but it's true. I mean, the more elements that you include in a system, the more observability components you have to have, the more data it generates. It's a compounding problem, and it's something that I'm looking forward to things like the Open Telemetry effort to help solve some of these things. The
Yeah.
ability to have systems that can kind of configure on the fly or request the observability components. Those are exciting things to me. Personally,
Yeah.
I'm excited about the prospect of DPU technology being involved in monitoring workloads. So instead of doing it on the CPU that the host has to do all the other things, you do it on a sub CPU that is nearby and tasked for observability. I think those things are pretty cool.
Yeah, offloading a lot of the data enrichment pieces in terms of what is being collected and how it's being shipped out, and being able to do that in hardware locally there at the node. That's potentially a game changer.
I
For
I
sure.
oh,
agree.
it's
I agree.
yeah, it's cool, and I think eventually we're going to have many PUs that are tasked with doing different things. You
Oh,
almost
I
have
hate that,
to,
Lori.
right?
I just
I
hate
know,
that.
I know
I
you
have a
hate it, but
GPU and a CPU and a DPU and an NPU and a PU.
IPU, QP, barbecue. I just want a
Nice.
barbecue on my we're we're past time with that because if we go further, it's going to get terrifying. So, what can your typical enterprise again doesn't have 30,000 GPUs or CPUs to reclaim, but still wants to explore this, to get it right, to do something about it before it becomes a problem. Because AI is not going away; it is multiplying the problem. Aside from a dart, which I mean, I like that, Chris, but I don't think that's really a strategy that most CIOs would take. What's your advice? What should they learn from
Sure.
OpenAI's mistakes?
Start by top down. Where are you spending all your money? What are the expensive things happening? Because probably if you can shave 1% or 2% off that, then you're going to have more impact than shaving 100% off a thing that doesn't matter. So
Yeah.
use your observability data to figure out where the resources are going, and then start there. Dive in. Go as far as you can with the metrics and the high level stats about what time is being spent doing which things. As you drill into that, you'll find naturally that at some point you'll get to a space where you say, okay, this is taking a long time. Does that make sense or not? Something like a profile that can really help you figure out whether that is, what is expected or not. So being able to kind of drill down from the very high level, like, hey, the CPU usage across our fleet is this, down to the very specific, this process is running this syscall a billion times and that looks bad. That key, having the availability of data to do that is key.
Yeah.
And it exists in more places today than it did definitely 10 years ago. So let's go use it, I think.
Yeah, and I agree. I think monitoring and learning how to run profiling, I think that's a really important aspect. And not forgetting to optimize. A lot of time is spent optimizing applications. Very little is spent on optimizing the host that runs the application. And I think that's important to realize. What I've learned is that logging is not free. Logging is only free in the sense that it's not like free parking or free lunch. It's more like free puppy, free kitty, or free child. There are downstream costs to this transaction.
Oh, wow. I would say, right, measure what matters. Figure out what matters to you. If it's cost, if it's performance, right? Measure those things. Actually pay attention to it. And cost is going to be a big one. And right, don't measure necessarily things that don't matter. You don't need to, right, resolve every IP address in real time. Okay. Like you can do that later, probably. It's really, you want the basics. So with that, that's a wrap for Pop Goes the Stack. Tap subscribe. Why is that word so hard to say? Subscribe. Say that. You guys
subscribe. Hit that subscribe.
Subscribe. Tap the button that lets you know when another episode is out. Okay? Stash some backups and rendezvous here for the next meltdown. Keep your pager on ready.